Welcome back. The topic of this interactive video lesson is an introduction to the cosine law. Let's start by reviewing SOH-CAH-TOA. We already learned how to use the sine, cosine, and tangent to solve right triangle problems. Remember, the sine of angle A is the opposite divided by the hypotenuse. The cosine of angle A is the adjacent divided by the hypotenuse. And the tangent of angle A is the opposite divided by the adjacent. Now we'll learn how to use the cosine law to find the side lengths or angles of any triangle. The cosine law for all triangles is defined as follows. 1. The square of any side in a triangle, such as side length A squared, is equal to the sum of the square of the other two sides minus twice the product of these sides multiplied by the cosine of the angle between these two sides. Notice the letter pattern in the equation. We have ABC, CBA. The cosine law can be used with any triangle. We just relabel it to fit our needs. If we need to find the length of side Y, we can relabel the triangle and solve for A. If we need to find the length of side C, we can relabel the triangle and now solve for A. Just remember, side A is across from vertex A, side B is across from vertex B, and so on. Let's let B equal 12, C equal 7, and angle A equal 54 degrees. Use the cosine law to find the length of side A. Let's start by writing the cosine law. Substitute the given values for B, C, and A. Now solve the equation by following the order of operations, or BIMDAS. First, we start with what's inside the brackets. That's cosine of 54 degrees. We can use a scientific calculator set on degree mode. This is an irrational number, but we'll round to 3 decimal places. Now, exponents. Now, multiplication. Finally, the addition, and then the subtraction. Finally, let's take the square root of both sides. We should have a plus or minus out in front of this, but since we can't have a negative distance, we'll only deal with a positive. And we see that A is 9 and 71/100ths. So the length of side A is 9 and 71/100ths units. Let's try a different problem. Find the length of side Y. Let's replace side Y with side A and vertex Y with vertex A. Now replace vertex Z with B and label the opposite side B. Change vertex X to C and label the opposite side C. Solve for A using the cosine law. Let's write this out. Substitute the values for B, C, and angle A. Now use BIMDAS, solving the brackets for cosine first. Again, we round to 3 decimal places. Now, exponents. Then the multiplication. Finally, the addition, and then the subtraction. Then we can take the square root of both sides. Now side A, which was side Y in the original diagram, has a length of 8 and 55/100ths units. There are 2 versions of the cosine law called Theorem 1 and Theorem 2. Here is Theorem 1. We've already seen this one. And here is Theorem 2. we use Theorem 1 to find the length of side A. We use Theorem 2 to find the measure of angle A. When we know all three side lengths, we can find the measure of any angle. For instance, if these are the side lengths, let's start with Theorem 2. If we wanted to know what angle A was, we can substitute the side lengths for A, B, and C into the equation. Now we follow BIMDAS. We solve the exponents first, then the multiplication, then we add and subtract in the numerator, and finally we use a scientific calculator to find the inverse cosine of 1/154. And we see that it's 89 6/10 degrees. Now we'll find the measure of angle C. This requires us to relabel the triangle, so let's write in the side lengths first. Now relabel the triangle so that vertex C becomes A. Now relabel the sides based on the new letters of the vertices. Now write Theorem 2, then substitute the values for A, B, and C. We're using the new A, B, and C here. Now use BIMDAS, starting with exponents. Then we multiply on the denominator. Then we add and subtract in the numerator. Now we use a scientific calculator to find the inverse cosine of 241 divided by 286. And that's 32 6/10 degrees. Now we know that the sum of the interior angles in a triangle is 180 degrees. We know two of these angles, so we can solve for the third. Summing, and then subtracting, we see that angle B is 57 8/10 degrees. We could have used the law of cosines to find this as well, but this one is a little bit easier when you know two angles. All right, now you're ready for more examples and practice.